Hello everyone, today I'm going to talk about question 24. Three identical point charges are released from rest at the corners of an equilateral triangle as shown in the diagram. Each charge has a charge of positive 1.2 microcoulomb and a mass of 5.4 times 10 to the power of negative 3 kilograms. Find the speed of the charges when their distance from the center of the triangle doubles. Since all three charges are in identical situations, they move in the same way and therefore have the same speed. Let r be the initial distance between charges. Since the triangle remains equilateral throughout the motion, when the distance from the center doubles, the distance between any two charges also doubles and becomes 2r. To solve this problem, we use the formula F applied times d plus 1 over 2m v initial square plus kq1 q2 over r initial equals 1 over 2m v final square plus kq1 q2 over r final. Because no external force is mentioned, F applied times d is 0. The charges are also released from rest, so the initial kinetic energy is 0. Therefore, the equation becomes kq1q2 over r initial equals 1 over 2m v final square plus kq1q2 over r final. Initial distance is r, and there are three pairs of identical charges in the system, so the initial electrical potential energy is 3kq squared over r. All three charges have the same speed, so the final kinetic energy is 3 times 1 over 2m v final square. The final distance is 2r, so the final electrical potential energy is 3kq squared over 2r. Subtracting 3kq squared over 2r from both sides, we get 3kq squared over r minus 3kq squared over 2r equals 3 times 1 over 2m v final square. Put 3 outside, we get 3kq squared over r minus kq squared over 2r equals 3 times 1 over 2m v final square. Dividing both sides by 3, we get 1 over 2 kq squared over r equals 1 over 2m v final square. Also, cancelling 1 over 2 on both sides, we get kq squared over r equals mv final square. Final velocity is the square root of kq squared over mr. Now, we substitute the values. K is 9 times 10 to the power of 9, Q is 1.2 times 10 to the power of negative 6, R is 0.8, M is 5.4 times 10 to the power of negative 3. Therefore, the speed of three charges when their distance from the center of the triangle doubles is approximately 1.73 meters per second. Thank you for listening.